A formula for the area of a triangle follows from the formula for the area of a parallelogram. If we go back to our original parallelogram and cut it along the diagonal, we could prove that the two triangles formed are congruent. Thus the area of each of the two triangles formed is 1/2 the area of the parallelogram. Therefore, the area of a triangle with base of B and height of H can be found by multiplying 1/2 the product of the base and the height. Remember, in a triangle, a line segment drawn from a vertex of the triangle perpendicular to the side opposite that vertex is the altitude or height to that side, and that the altitude may not necessarily lie in the interior of the triangle. Next, let's develop a formula for the area of a trapezoid. Consider this trapezoid. If we take another trapezoid the same size as the original, turn it over, and put the two trapezoids together like so, it forms a parallelogram with height of H and base of length B sub 1 plus B sub 2. The area of the parallelogram is the product of the length of the base and the height, which in this case would be the quantity B sub 1 plus B sub 2 times H. Remember, our original trapezoid is 1/2 this parallelogram. Thus the formula for the area of a trapezoid is area equals 1/2 the sum of the bases times the height. Let's look at a rhombus as we develop a formula to find its area. We will base our formula on the fact that its diagonals are perpendicular and bisect each other. Thus the diagonal of a rhombus divides it into two congruent triangles, each with an altitude equal to 1/2 the length of the other diagonal. The area of each triangle then would be 1/2 the product of the base, which is a diagonal, and the height, which is 1/2 the other diagonal. From this we can write the area of a rhombus is equal to 2 times 1/2 the product of the diagonal and 1/2 the other diagonal. This can be simplified to the area of a rhombus is equal to 1/2 the product of the two diagonals.